All right, now it's time for our last problem. Y equals 1 divided by cosine of x to the fifth, all of that squared. First thing I'm going to do is I'm going to rewrite this just a little bit to make it look a little bit prettier. And we'll get cosine of x to the fifth to the negative 2. So I'm going to write it like that. We could leave it like this, but I think it looks a little bit prettier when I look at it like this. Now, what I see is I see an outside function, which is right here, and then I see an inside function inside of that. And so I've got my outside, which is my x to the negative 2. Outside is x to the negative 2, and then my inside is cosine of x to the fifth. So if I want to do my derivative, my x to the negative 2 comes out pretty easy. It's negative 2 x to the negative 3. Make sure we're subtracting. Now my inside is where I get into a problem, because what you'll notice is that now I have another inside of what I have. So now I've got a second inside of that. So what does that mean? That means I'm using a second chain rule. So the first thing I did was I started with the chain rule with this is my inside and that is my outside. And now I've got a second chain rule again. So now once I have my second chain rule, I can start to work it out, where I've got my derivative of its inside, and let's just write them out clearly. My derivative of its inside is 5x to the fourth times the derivative of the outside. Derivative of cosine is negative sine of x, but remember we don't leave the middle, so we leave it as x to the fifth. So now here I've got my inside and my derivative of my inside. So the derivative of x to the fifth is 5x to the fourth. Derivative of cosine is negative sine. So what you see I'm doing when I'm doing all these problems is, as I'm breaking it up, I break up into pieces, and then each piece I have to follow the appropriate rules. So if I gave you a problem that ignored all of this and just said find the derivative of cosine x to the fifth, this is what you would get as your answer. And then we have to combine these answers together into our final, more complicated solution. So again, let me pull out a second piece of paper so that we can see all of this. And let's start writing down our final answer. So what is my final answer? My final answer is the derivative of the inside, which is right here, 5x to the fourth times negative sine of x to the fifth. Now what's the last thing I have to do? Now I have to multiply that by the derivative of the outside, which is negative 2x to the negative 3, but I don't want to write the x. I have to put the inside back inside of it. So this part right here, right? So this part right here is what has to go inside of there. So I get cosine of x to the fifth to the negative 3. So this is our final answer. By the way, there are a lot of different ways you could have approached this problem that were different from the way I did it. You could have used a quotient rule here. Again, you could have, instead of doing this as the inside, you could have switched the way your insides were. You could have used the inside as x to the fifth and the outside as cosine of x to the negative 2. And so there were different ways you could have approached the problem. This was the one that made the most sense to me. But before we go on, I want to rewrite that problem just one more time, because I want to look at what we've got. So the problem was y equals cosine of x to the fifth to the negative 2. And so I kind of want to look at all of this together. And what you'll see is that we have an outside, which is right here. Tell you what, let's not write it like that. So, so we have our outside, which is the whole piece, and then we had our inside, which is that piece, and then we had our inside, which is that piece. And so what you can see is, you can see that we've got an x to the fifth inside of a cosine inside of a negative 2. And you can imagine that we could keep nesting functions inside of functions for as long as we wanted. So we could have something inside of something inside of something inside of something. It kind of makes you think of Inception. But if you look, you'll see what our picture is. We started with the innermost. We started with the innermost function, and we have its derivative all by itself. And now we have the secondmost function, and then its derivative is connected to that. So we have the innermost, and we just kind of started moving from the inside out. X to the fifth became 5x squared. Cosine became negative sine, except you have to leave the inside in it. And finally, you have this outermost function, and its derivative is right here on the outside. And so once you get good at this, you'll get to where you don't have to write out all the details that I have. You can just start looking at your equation going, okay, let's just start from the inside out and do x to the fifth is 5x to the fourth. Cosine is negative sine. Leave the x to the fifth. Negative x to the negative 2 is negative 2 to the negative 3. Put all that inside of it, and we're done. Conversely, you could work from the outside in because we know the order you multiply doesn't matter. You could say, let's do the negative 2 first. Now let's do the sine. Now let's do the x to the fifth and kind of work your way that way. Combining a whole bunch of chain rules and being able to do them quickly and efficiently is really helpful as you move through mathematics. Well, I hope that working these problems helped. What you need to do is you need to do a lot of these problems. I have a bunch of homework problems for you to do. But this is really something that the only thing you can do is do them over and over and over again. You just need to burn the chain rule, the quotient rule, and the product rule into your mind where you're doing them in your sleep. And then from now on, when you do a math class, every time you take a derivative and there's a product, you know it's a product rule. And every time you do a derivative and it's an inside, it's a chain rule. And there you go. So I hope this helped, and I will see you next time or in office hours.